Hello students, in this video we will going to discuss some topics of unit 10, that is elements of building construction. Let us see which topic which we will going to cover in this lecture. So as you can see here, this all are the enlistment of topics of this chapter. But in this video, we will going to discuss these highlighted points, highlighted topics, that is building components in a detail. So we will going to discuss it because these two topics we already discussed in the previous lecture or even in the regular classrooms. As of now, we will only going to focus on the topic building a component in this lecture. So let us go through the slides. So as you can see this diagram, okay, so this is a diagram of showing some important parts of building or some important parts of structure. As you can see here, see, this particular diagram is drawn by cutting a section from the wall, so you can assume the all the structural component, and I will going to explain you in a detail. So let us start with the ground level. Okay, all we know that a building is resting over the ground level, and some part of building is there which is constructed below ground level. Okay, so as you can see here, this is ground level, this is part of building which is constructed below ground level. So which part of building is constructed below ground level? The answer is foundation. Okay, so this is what foundation which is constructed below ground level. Okay, and as you can see above ground level, right, above ground level, whichever part of buildings are constructed are said to be superstructure. Okay, so let us differentiate substructure and superstructure. So as you can see, substructure means the part of building which is constructed below ground level is said to be substructure. And opposite to this, the part of structure which is constructed above ground level are said to be superstructure. Okay, so let us enlist the superstructural and substructural component. Okay, so as you can see here, which part of building is constructed below ground level? The answer is foundation. Okay, so as you can see, now we're going to discuss the superstructure component. So this is ground level. So above ground level, or you can say above ground level, the very first is plinth level. Plinth level is what? The level between the ground level to the finished floor level, and finished floor level is the very first floor on the ground floor is said to be finished floor level, of which is made up of the kota stone, marble or tiles. So from ground level to the finished floor level is said to be plinth level. Okay, so plinth level is also part of superstructure. Then floor, then door. Okay, above door there's a concrete horizontal structure, remember, that is said to be lintel. Okay, so plinth, door, lintel, again wall above lintel, and at the end of wall, for the very first floor or the very first ground floor, at the end of wall there's a slab, and above slab there will be flooring again, and above flooring there's a wall, and above wall there's a window opening. So if we talk about this window opening, at the bottom of the window opening there's a sill level which is similar to the lintel, but it is provided at the bottom of the window opening. Okay, so this sill level or sill, window opening, at the top of window opening, lintel similar to the top of the door. After a lintel there is a again wall, and at the end of the wall of the first floor there is again slab, and that slab is said to be roof slab, or it is said to be terrace. And this is the a small height of thin wall which covers the terrace area is said to be parapet wall. Okay, so ranging from parapet to ranging from parapet to plinth, all the parts are said to be superstructural component. Okay, and the below ground level, whatever part of building is there as a foundation, it is said to be substructure. Okay, so based on this diagram, based on this concept, we will going to proceed with the next slide. So as you can see here, the building components are basically categorized or classified as superstructure and substructure. Already we discussed in the previous slide the different superstructural component. Say for example, plinth, damp proof course, that is DPC, walls and columns, floors, beams, roofs and slabs, lintel, chhajjas or weather shed, doors, windows, parapet, steps, stairs, coping. Okay, all these components of building are lying above ground level. That's why it is falling under the category of superstructure. Okay. Next is substructure. Okay, as a substructure, we have foundation which is constructed below ground level. Okay, so these all are name of building component as a building components as a superstructure and substructure. So in the next slide, what we will going to do is we will going to discuss different definitions of building component or basic nominal definitions of building component. Then we will going to discuss the functions of all these building components, and then the nominal dimensions of all these building components. So let us go through a next slide. Okay, so here as you can see this this picture already we discussed. So based on this picture, let us discuss the definition. Okay, so we'll start with the bottommost part of the building, that is foundation. Okay, as you can see, the very first definition is of foundation. Okay, so can we say that a foundation is that part of structure which is constructed below ground level. Okay, second way we can define it like it is the lowermost part of any building. Okay, so it can be defined like it is a structure which is constructed below ground level and it is the lowermost part of the any building. Okay, so this way the foundation can be defined. Next is plinth. As you can see here, this is ground level, this is plinth level, and the difference between the ground level and the plinth level is constructed of the like broken pieces of stones and the masonry and then soil and then the DPC, and then the ultimate flooring can be done. So this layer can be constructed with this. Okay, as you can see, this is ground level where the soil, you can see the soil which is showing the ground level, and this is said to be the plinth beam. Okay, so after filling the brick bats and broken pieces of stones and murams here, the ultimate finished floor level can be done. So the difference between this ground level to the finished floor level which can be done here, it is said to be the plinth level. Okay, so as you can see, plinth. Okay, can we say that? Okay, all we know that the superstructure is above ground level, right? So can we say that the plinth level is the lowermost part of superstructure? As you can see here, from this level the superstructure starts, right? So plinth is at the bottommost part of the superstructure. So this way we can say that it is the lowermost part of superstructure of any building, and this level is existing from ground level to the finished floor level. Also you can see here. Okay, next is wall. As you can see, walls are constructed by the use of bricks, stones, concrete blocks, and all these bricks, stones and the concrete blocks are bounded together with the mortar. In the earlier time, the walls were constructed of stones, maybe rubble coarse masonry or uncoarsed masonry, right? But nowadays but nowadays not only but instead of a conventional brick, advanced material is used for the construction of wall, and the name of that material is AAC block. which is quite lighter as compared to conventional brick, and its strength is quite higher as compared to brick. So it can be used along with the mortar to construct wall. Next is column. Okay, so as you can see here, you won't be seeing the column here because this is a cross section cutting from the any building. Okay, let us discuss the column. What is column? Column is isolated vertical load bearing member. It is vertical load bearing member. Load bearing member means the member whose function is to bear the load, to transfer the load. Okay, so the column is isolated vertical load bearing member which is of small section and made up of brick, stone masonry, or of reinforced cement concrete. Okay, in the earlier time the columns were made up of, or the vertical load bearing member made up of bricks and stone masonry, but nowadays in case of RCC frame structure, all the columns are made up of reinforced cement concrete. So this is what definition of column is. Next is stair. Okay, stair is comprised of series of steps which connect one floor to the another floor, or which connects different floors. Okay, then parapet. Okay, what is parapet? I have already like shown you here in this diagram. This is terrace. This is a small height of thin small height of wall which encloses the terrace area, and that is said to be parapet. Okay, so low height thin wall which is constructed above the slab at the terrace area is to enclose the terrace area is said to be parapet wall. Let us continue with the next slide. Okay, then roof and slab. So if we talk about roof slab, okay, see this is also considered as a slab. See the diagram. This is also considered as a slab. Okay, this is also considered as a floor. This is also considered as a this floor. But if you talk about roof slab is considered to be that slab which covers the area below. Okay, which covers the area below, which covers the space below. So roof slab is the uppermost part of the building to cover the space below. Next is door. So for the door we can see that it is a frame. As you can see, it is a frame and a shutter. Okay, it is a frame and shutter made up of wood, steel, glass, aluminium, or a combination of all this material which is secured within the wall opening from finished floor level to lintel level. Please see this diagram. As you can see here, it is a frame and shutter made up of wood, steel, glass, aluminium, which is secured within the wall opening starting from finished floor level to the lintel level. Okay. Next is window. Similar to the door, it is a frame and a shutter made up of wood, steel, glass, aluminum, or combination of all this material which is secured in the wall, or which is secured in the wall opening, but from seal level to the lintel level. Okay, so this window is always provided within the wall opening from seal level to the lintel level. Okay, next is ventilators. Ventilators are a small window which is secured in a wall at the greater height for the purpose of lighting and ventilation. Next is floors. Okay, the floor is as you can see here, it can be floored, it can be one floor, or it can be one floor. But here we are first talking about the floor at the ground level. Okay, so the floor is constructed at the plinth level is said to be ground floor. See, this is ground floor, this is first floor, and for this sketch, this is said to be terrace or roof floor. Okay, so the floor which is constructed at the plinth level is said to be ground floor. Okay, and the floor which is constructed at each stories are said to be upper floors, and the floor constructed or the topmost floor of any of the building is said to be terrace. Okay, see, the phenomena will be getting changed as per the that way of seeing is getting changed. All these three floors are said to be floor, but this is said to be ground floor, this is said to be upper floors, and for this sketch this is said to be terrace. Okay, good. Next is lintel. Okay, as you can see here, this is door opening. At the top of the door opening, see this sketch. At the top of the door opening, there's a provision of lintel. There's a provision of horizontal concrete member above the door opening. Okay, so I have taken picture here. You can see this. This is what? Door opening. Okay, at the top of the door opening, one horizontal concrete member is constructed. Okay, so that is said to be lintel. Okay, so it is defined as horizontal structural member which is constructed across the opening of doors and windows. Remember one thing, lintels are provided above door and window opening. As you can see in this sketch, this is lintel provided at the top of window opening. Again, lintel provided at the top of the door opening. Okay, good. Next is arch. Okay, this is not arch, this is arch where my cursor is moving. Okay, so what is arch? Arch is wedge shaped blocks of stones or bricks which is joined together with the mortar and is provided across the opening. Okay, so this is said to be arch. Next is sill. As you can see here, for this window, at the bottom of the window opening there will be sill. But if we talk about door, there won't be any sill because the door itself will start, or door itself starts from the ground level, or you can say from the, sorry, not from the ground level but from the finished floor level. So if we talk about sill level, it is horizontal. It is a horizontal member which is constructed below the window opening. So as you can see here, this is sill and this is lintel. Okay, so this is constructed below this window opening. Okay, next is beam. Okay, so as you can see in this diagram, beam is not visible, but above this column and walls or below this slab, there is a construction of beam. Okay, so let us discuss the definition of beam. So what is beam? Beam is horizontal structural RCC member, horizontal structural reinforced cement concrete member which is provided below slab and resting over the walls and columns. Okay, next is weather shed. Okay, weather shed is, as you can see here, as this is window, at the top of the window at the lintel level the weather shed is provided, not for the windows only, it can be provided for ventilators, for verandas and for the doors one, but for the door it can be provided in the entrance. Okay, so let us see what the weather shed or chja is. It is small slab, it is small slab which is constructed at the lintel level above door, window, ventilator and veranda. Okay, and it is projected from the external walls. Okay, so this is what definition. Will continue with the next slide. Okay, so in this next slide we will going to discuss the functions of all the structural component whose definition we had discussed. So let us start with the next slide. So we'll start with the foundation. Okay, so as you can see, this is the foundation which supports the whole superstructure. Yes, which supports the whole or provides stability. So it also provides a stability to a superstructure and also transmits the superstructure load. So let us discuss foundation. Okay, the function or the purpose of foundation is to transmit the superstructure load. As you can see in this diagram, this load of all this superstructural component is transferred to the foundation, and from the foundation it is transferred to the subsoil below the footing. Okay, so one more, it supports the superstructure, it provides stability to the superstructure, also it prevents entry of it prevents effect of expansion and contraction of the subsoil. Now you must be wondering, is it possible that soil can be contracted and expanded? Yes, for a problematic kind of soil such as black cotton soil and bentonite clay, or a highly compressible soil or clay, the tendency of soil is having getting swelled in the presence of water and getting shrink in the absence of water. So that is swelling and shrinking itself is expansion and contraction that can be possible in case of soil. Okay, so the foundation, there's a particular type of foundation which prevents this contraction and expansion of soil. Okay, so this is what function of foundation is. So as you can see here, I have written some types of foundation. That is wall foundation, the column foundation. But in a detail in the upcoming lectures, we will going to discuss this types of foundation. Next is plinth. Okay, as you can see here, this is plinth level. Okay, so can we say that a plinth transmits all the superstructural load to the substructure? Yes, it transmits or transfer the superstructure load to the substructure. Also, as you can see here, at the plinth level, the DPC, that is dam proof course, is provided. At this plinth level, the DPC is provided. It means it prevents entry of moisture, bacteria, termite, rainwater, insects from this subsoil to the finished floor level, right? So it prevents entry of all this moistures, bacteria from finished floor from the subsoil to the upper layer of finished floor level. Next is wall. Okay, so as you can see, wall can support beams and slab. Okay, it transmits the superstructural load, but only in case of load bearing structure. In case of frame structure, the loads are transferred to the columns only. Okay, so in case of only load bearing structure, the function of wall is to transmit the loads. Next is it covers the building sites. It provides partition, privacy and safety. Also it provides protection from the heat, cold, rain, noise, fire, dust and wind. Okay, so the function of wall could be to transmit the superstructure load, to support the slab and beam, cover the area, provides partition, safety and privacy. Okay, good. Next slide. As you can see here, floor. The function of floor could be to provide simply a plain surface for the occupants, furniture and for the equipment. Next is roof. Okay, as you can see in this diagram, this is what roof is. So the function of roof is to enclose the space below. Okay, so that it can protect from the rain, heat, snow, wind, fire and sound. Next is door. So as you can see here, door, if you talk about door, it provides entry and exit to any building. It provides privacy and safety, internal, and it also provides lighting and ventilation. So its purpose is to provide entry and exit, safety and privacy, lighting and ventilation within the building. Next is window. Okay, it similar to the door, it provides lighting and ventilation, but along with that it also gives exposure to external views. Okay, next is step. So steps provide access to any building from the ground level. As you can see here, this is ground level, this all are steps, so it gives access to any building from the ground level. Next is stairs. So stairs is comprises of number of steps together, which gives a vertical circulation from one story to another story or one floor to another floor, or it is a means of providing a vertical circulation. Next is lintel and arch. As you can see here, the lintel is provided at the top of the door opening, also at the top of the window opening. So its function is to support the loads of wall above the opening. Along with that, it supports the load of door and window material and the frame. Similar to the seal, it provides support to the window opening for the frame and shutter of window material. Okay, next is beam. Okay, as you can see, you won't be seeing the beam here, but above this wall and below this slab, there's a provision of beam. Okay, so beam transmits and absorbs the load coming from the slab of the building, and it is transferred to the column. Okay, so it absorbs and transmits the load coming from the slab of the beam. Next is weathershed or chajars. Weathershed and chajars are provided to protect from the rain, sun and heat. The very last is parapet wall. Parapet wall is to enclose the terrace area. So here this is we discussed about definitions and functions of a building component. So in the next slide we will going to discuss the nominal dimensions of all the structural components. As you can see here, we are going to start with the depth of foundation. Now what is depth of foundation? Let us have a look here in this diagram. Depth of foundation is the depth from this ground level to this bottom of the footing. Okay, so this is depth of foundation from this ground level to this bottom of the footing. Okay, so this depth of foundation can be found if this thickness of wall is known. Okay, so with respect to this thickness of wall T, the depth of foundation from the ground level to the bottom of the footing is equals to greater than or equals to 2 times T plus 30. T stands for thickness of wall. Okay, so let us say if the thickness of wall is 20, so 2 times 20 plus 30, so it will be 70 centimeter as the depth of wall from the depth of foundation from the ground level. Similarly, next is width of foundation. As you can see, from here to here, okay, from here to here is the width of foundation, and the formula for finding the width of foundation is equals to 2t plus 30 equals to 2t plus 30. T stands for thickness of wall, this thickness of wall. Okay, so if we know the thickness of wall, let us say 30 centimeters, so 2 times 30 plus 30, that is equals to 90 centimeter as the width of foundation if the thickness of wall is known. See, this is for wall footing only. The plinth height. Plinth height means the height from ground level to this plinth level. So this plinth height can be 30 to 90 centimeters. Okay. Next is wall thickness. This wall thickness. Now see, the wall thickness will be depending upon whether the wall is of partition or load bearing walls, because load bearing walls transfers or transmit the superstructure load, so its thickness will be higher or thicker as compared to the partition wall. So partition wall, the thickness is 10 to 15 centimeter, and for the load bearing walls the thickness is 20 to 40 centimeters. Next is seal height. Now always remember, see in this diagram, seal height is always taken from the finished floor level. From this finished floor level to this height is said to be seal height, and it is taken equals to 70 centimeter from the finished floor level. Then sill thickness. Whatever sill is provided here, so what could be thickness of this sill is from 0.07 meter to 0.1 meter. Okay. Then lintel height. Lintel height is from this finished floor level. So lintel height can be from this finished floor level to here, so that it is about to 2 meter. 2 meter from here, and again 2 meter from this finished floor level. Then lintel thickness of this lintel, it can be equals to 10 to 15 centimeters. Sorry, one is remaining, lintel length. As you can see, the length of this lintel, okay, the length of lintel is always equals to width of door or window opening plus 10 centimeter of extra projection on the both the side. Okay, this is what width of door and window opening plus 10 centimeter on the left side and 10 centimeter on the right side of the opening. Okay. Next is door width. See, the door width and the door height or the door size will be depending upon which like which door it is. Like if you talk about WC and bath doors, its dimensions will be different. If you talk about door at the entrance, it will be different. So, but the nominal door width is given, which is ranging from 0.8 meter to 1.2 meter. Similarly, door height ranging from 1.8 meter to 2.10 meters. Similar for the window width and depth. See, this window width and depth or windows dimensions will be depending upon the area of room or the size of room. Okay, so it is ranging from the 0.6 to 1.8 meters. Next is Chaja projection. Okay, so Chaja projection is of 30 to 90 centimeter and thickness will be more within the wall and less at the outer side. So it is said to be a this kind of tapered section. 0.1 meter to 0.07 meters. Within the wall, it will be having more thickness, and at the projected area, it will be 0.07 meters. Column size and column type. See, this is not, even though I have written here the nominal dimensions, but basically the size of column, the type of column will only be depending upon the how much load is coming over one column or depending upon the structural design. Though I have written here for the square column 20 by 20 or 30 by 30 centimeter, for the rectangular column 20 by 30 centimeter, and for the circular column 20 times 25 35 centimeter. Okay. Then for the column footing, the pitch size is given 1 cross 1 meters below ground level. Then the depth of beam, it is also varying from 30 to 60 centimeters, and the width of beam, see, the depth of beam and the width of beam also will be depending upon the how much load is coming over beam. Okay, but still the nominal dimensions are given, so it is equals to the width of wall and maybe raised up to 30 to 60 centimeters. Next is slab thickness. Again, this will be depending upon the structural design and how much load is coming. Still, it is given 0.1 to 0.15 centimeters. Thickness of parapet wall is only 10 centimeter. Parapet height is 1 meter to 1.3 meters. And now this is steps. Okay. So, what is riser, what is stride, we will discuss in the upcoming slides. So, the number of risers can be found if the height of ceiling slab thickness is known. Then we can find the number of riser, and number of treads are always equals to number of riser minus 1. So, here we are concluding the nominal dimensions of structural component or building component. So as you can see here, this one diagram or picture I have taken. So this is ground level, this is foundation below ground level, this is said to be plinth, above plinth there is a floor, okay, and from plinth level to access to the building there will be steps, this walls, these all are building services. This is roof or slab, you can say. This is again slab. There will be some. There will be the column here at the junction. This is said to be ceiling, window. This is floor. Okay. So these all are building components. Now let us discuss in a detail about substructure and superstructure. Already we discussed about substructure is what? A part of building which is constructed below ground level is said to be substructure. Or superstructure is part of building which is constructed above ground level is said to be superstructure. Okay. So let us discuss in a detail about substructure. As you can see, suppose this is ground level, this is column which is extended below ground level, and this is footing at the base. Okay, so that's why this is said to be a column footing. Okay, again this is ground level and the column is extended below ground level, and ultimately at the bottom the footing is constructed. So this whole part below ground level is said to be footing or foundation. See, the whole phenomena is foundation. Okay, and the bottommost part of foundation which is in contact with the subsoil is said to be footing. So this is what whole foundation, and the bottommost part of this foundation which is in contact with the subsoil is said to be footing. As you can see here, this is what reinforcement. So let us discuss. So it is that part of building which is constructed below ground level. Okay, constructed below ground level. It transmits the superstructure load to the subsoil. The load will be transferred to the through the column to the foundation, and from the foundation to the subsoil. And the soil immediately below this footing is said to be subsoil. Okay, so the foundations are considered to be the lowermost part of the building which is in directly contact with the subsoil. Okay, so that is said to be footing. Okay, so simply the function of substructure is to transmit dead loads, superimposed loads, live load, and all the loads of building to the soil on which the building is resting. So let us see the types of foundation. So as you can see here, this is ground level. Okay, this is again ground level, right? There are basically two types of foundation. One is shallow foundation, one is deep foundation. See, by hearing word shallow itself represent not much deeper, and deep foundation represents some foundation which is deeper. Okay, so this is example of shallow foundation. This is example of deep foundation. Okay, as you can see here, this is ground level. See, this is example of column footing. Okay, this is ground level. As you can see, from ground level to the footing, this is said to, from here to here is said to be what? Depth of footing. And from here to here is said to be width of footing. Okay. So with respect to this depth of footing and the width of footing for the shallow foundation, similarly the depth of footing from here to here and the width of footing from here to here, this shallow or deep foundation can be classified. How? Let us discuss in the upcoming slides. Okay, as you can see here, when the depth of foundation is less than or equals to the width of foundation, foundation is said to be shallow foundation. Okay, and when the depth of foundation is greater than the width of foundation, foundation is said to be deep foundation. An example of shallow foundations are spread footing, combined footing, strap footing, mat or raft foundation. An example of deep foundation is pile foundation. This is one example of typical wall footing I have taken. See, this is wall footing. As you can see, this, this is made up of masonry. Okay, so this is said to be, this is what wall which is extended below ground level. See, this is ground level. So the walls are extended below ground level, and then the RCC footing is constructed at the bottom. So this is example of wall footing. Okay, as you can see here, this is 20 centimeter thick wall footing. This is 30 centimeter thick wall footing. See, there's a difference in both this footing because of its thickness 20 and thickness 30. What is that? Let us discuss here. See, for the 20 centimeter thick wall footing, the number of steps will be 1 and 2. Okay, so number of steps will be only 2, or you can say the number of number of riser will be 1 and 2. Okay, so number of risers in case of 20 centimeter equal footing is 2. Okay, and the height of riser is 10 centimeter and the width of tread is 5 centimeter, and the distance from the riser, last riser, to the edge of the footing is 15 centimeter. Okay, and this is what footing, which is made up of reinforced cement concrete. Okay, this RCC footing is having its thickness is equals to thickness of wall. If this is 20, this will be 20. Okay, and this is what width of footing. This width of footing can be found from this thickness of wall. As we have discussed, the equation is 2t plus 30. So as you can see here, 2t plus 30, 2 times thickness of wall to 20, so 2 times 20 plus 30 is equals to 70. That's why the 70 is the width of wall footing. Understood? Similar for 30 centimeter thick wall footing, as you can see here, the number of steps will be 1, 2 and 3. So number of risers are 1, 2 and 3 risers are there in case of 30 centimeter thick wall footing. Rest of the dimensions remains the same, only the thickness of footing and the width of footing will be different. As this is 30 centimeter thick wall footing, this thickness will also 30 centimeter, and this 90 is found from the 2t plus 30 equation. 2 times thickness of wall is 30, so 2 times 30 plus 30, 90. So this is the 90 centimeter of thick wall footing. Similar for 40 centimeter of 40 centimeter thick wall footing. As you can see here, 1, 2, 3 and 4. 4 rises are there. The height of rises remains the same. The width of tread remains the same. The distance from the last riser to the edge of the footing remains the same. The difference is of this. This is 40 centimeter thick wall footing. That's why the 40 centimeter is the thickness of footing. Okay. And it's 110 we are getting from the 2t plus 30. 2 times 40 plus 30 is equals to 110. So this is the 110 is the width of 40 centimeter thick wall footing. Okay. So let us see some the real pictures of foundation. As you can see, this is what column, this is footing, so this is said to be a single footing. As you can see here, column with one step, one more step. Okay, so this is said to be stepped footing. Okay, so this is what the whole phenomena is said to be foundation, and the bottommost part of the foundation is said to be footing, which is directly in contact with this subsoil. So this is stepped footing, this is single footing. Next is combined footing. Please see this diagram, see this picture. This is one footing, one more footing. Okay, so the spread footing is that which supports 2 or more columns. As you can see here, this one footing is connected with 1 and 2 columns. That's why this is said to be a spread footing. Okay, so the shape of this footing can be rectangular or can be trapezoidal. As you can see here, this is rectangular spread footing and this is trapezoidal spread footing. Okay, and these footings are made up of reinforced cement concrete. It is RCC. Reinforced means reinforcement, and along with this cement concrete. Okay. Next is strap footing. Strap footing means, as you can see here, this one column footing, another column footing, both the column footings are connected with this strap beam. Okay, so whenever the strap footings are consist of 2 or more footings which is connected by this beam, and that beam is said to be strap. So this is said to be a strap beam. Next is raft or mat foundation. See, raft or mat foundation is example of shallow foundation, which is constructed below the entire area of building. If you see, this is the entire area of whole building, and these all are the columns constructed at the building site. So at the this is raft which is constructed along with the below the entire area which supports all the walls and columns are said to be mat and raft foundation. Next is, see, in the previous slide, whatever we discussed, spread footing, then single footing, stepped footing, raft foundation, combined footing, strap footing, all were examples of shallow foundation. Okay, so here we'll discuss deep foundation. Okay, as you can see here, when the depth of foundation from ground level, see this depth from ground level and this width of this footing, when the depth of foundation is greater than the width, is said to be deep foundation. An example of deep foundation are pile foundation. Okay, as you can see in this picture, see, this is one pile, two pile, three pile. Okay, these piles are constructed of reinforced cement concrete. See, as you can see here, the reinforcement cage is driven, then the concrete can be done, and this way, or you can see this way, the piles can be constructed. Okay, so the piles are said to be type of deep foundations, and which is constructed to take more load at the greater depth by means of vertical member. Okay, so the piles may be constructed of timber, concrete, or steel, but nowadays most of the piles are constructed of only concrete and steel. This type of foundation can be adopted for the soil which is not having adequate bearing capacity or which is having a poor bearing capacity. Next is superstructure. So let us discuss about plinth. So what is plinth? As you can see here, this is plinth, which is between the ground level to the finished floor level. So the plinth is between the ground level and the finished floor level. Okay. So as you can see here, at the top of the plinth, a dam-proof course is provided. DPC, or you can say dam-proof course. Dam-proof. The function of dam-proof course is to prevent entry of moisture and the bacteria, or it keeps the finished floor level free from the dampness. Okay, so for the residential building, the thickness of a plinth or the plinth height should be more than 300 mm and about 450 mm, and it is required that the plinth level should be at least 150 mm above the road level, so that the connections to the underground drainage system can be made easily. Next is walls and columns. All we know that the function of walls and column is to transfer the loads of superstructure vertically downward to the foundation and from the foundation to the subsoil. Okay, so apart from this, it also encloses the building area into different compartments and provide privacy. It also provides safety and also keep building warmer in winter and colder in the summer. So if you talk about classification of walls, walls are of two types. One is load bearing walls and one is non-load bearing walls. So load bearing walls are walls which carry a superimposed load along with its own weight. So its thickness will be more in terms of 20 to 40 centimeter, and non-load bearing walls are said to be partition wall which doesn't carry the superstructure load, only carry its own weight, and it's having only a thickness of 10 centimeter. As you can see here, this is different way of lying the breaks, and this is like pin course, then pin course, and these different types of bonds. This is for your understanding point of view only, not part of your syllabus. Next is seal. Okay, so this is what window opening. Okay, so at the top of this window opening, one horizontal concrete member is constructed. Okay, so this is said to be lintel, and at the bottom of the window opening the sill level is constructed. As you can see here, the length of this lintel is equals to width of window opening plus some projections on the both the sides. Okay, so it is placed over the 50 to 75 thick plain concrete course which is provided over the masonry, and it is said to be sill. Then Lintel is, this is said to be lintel, which is provided at the top of the door and window opening to transfer the load of door and window frame and material. So this width of lintel is equals to the width of door plus thickness projected at the outside. This is chajaz. Okay, as you can see here, this is chajaz. So within the wall opening, the thickness is more, and at the projected area the thickness is less. That's why its projection is said to be a tapered section ranging from 600 mm to 800 mm, and this is constructed at the lintel level in case of doors, windows, verandas, or outside the external walls. Next is door. The function of door is to give the access to different rooms of building, and the number of doors should be kept minimum as much possible. And see, this is the dimensions of different doors for the external doors, internal doors, and the bath and WC doors. This diagram is showing different components of the door, but it is not part of your study. Next is window. Yes. Windows are provided to get the lighting and ventilation within the building. So it is constructed and located at the very greater height of 0.75 meter to 0.9 meter from the finished floor level. So in case of hot and humid regions, the window area should be kept 15 to 20% of the floor area. So the size of window should be depending upon the size of room, also the location of locality or the surrounding of building. Next is floor. See, this is the process of the steps of floor construction. Let us see. The floors are said to be important component of building, which gives plain surface for the occupants. So the very first, the ground floor is filled by the brick bats, waste stones, gravels, and that is well compacted with the thickness of 100 mm, and above that a sand layer is provided, and above that 1 gem 4 gem 8 of concrete is prepared, and it is laid down with the thickness of 100 mm. So on the top of this, a damp proof course is provided, and on the top of the damp proof course, the finished floor level in terms of tiles, kota stones, marbles can be provided as a finished floor level. So this is what process of floor. Roofs. Okay, so as you can see here, roof is said to be the topmost portion of the any building which covers the building from the top. Okay, so there are different types of roofs are available here: cross gable, cross heaped, flat, heap roof, gable roof, masons, pipe, pyramid, and salt box roof. All these types of roofs can be used depending upon the functional requirement and aesthetic point of view. Again, some types of roof. Next is steps and stairs. Okay, as you can see here, this is 1 2 3 4 steps which combine together forms stairs, which gives access from ground level to the upper stories. Okay, so as you can see here, this part of step where feet can be where the feet can be taken, or feet can be kept, is said to be tread, and the height of one step is said to be riser. Okay, so this is riser, this is said to be tread, and the whole phenomena is said to be uh, this staircase. Okay, so the number of steps will be depending upon the difference in the level of ground and first floor. Okay, between the level of this ground floor and the first floor, the number of steps will be taken, and always number of tread is always number of rises minus 1. This is again one diagram showing the terminology of stairs. This is tread, this is riser, this is said to be run. Okay, this is total height. Okay, again elements of stairs. What part of your study? Just understanding point of view I have taken.